Good morning, everyone. In the previous classes, we have discussed about reflection of light. Now, in this class, we are going to discuss about another important topic from light or optics, that is refraction of light. Let us see what is refraction of light and what are the processes which we come across in refraction of light. Now, let us see what is refraction. Refraction. So, refraction of light is nothing but the process of bending of light when light enters from one transparent medium to another transparent medium, or we can say that as the process of deviation in path of light or change in path of light when light is entering from one transparent medium to another transparent medium. So what we are saying in this is the light will undergo change in path, or there will be deviation in path of light when it is entering from one medium to another medium. So we are considering about two mediums here. Let us see what are those two mediums. One is rarer medium and the other one is denser medium. Let us see rarer medium and the second one is denser medium. Denser medium. So what happens when light enters from rarer medium to denser medium or denser medium to rarer medium? So we will say that as light undergoes change in path of light, or there will be bending of light takes place, or change in deviation of path of light. Let us see when light is entering from rarer medium to denser medium. Let us see this. Let us take first condition as light is entering from rarer to denser medium. Rarer medium to denser medium. Rarer medium to denser medium. Now consider this as an interface between two mediums. Interface means separation between two mediums, and the medium above this, let us take this as first medium, that is rarer medium. Rarer. And the medium that is below this interface line, we take that as denser medium. So denser medium. So draw a perpendicular to this. This acts as a normal. Now if we consider that a light ray is coming from rarer medium to denser medium, let us consider this. A light is incident obliquely and it is meeting this interface line at one point, and let this be angle of incidence. And when light is entering from rarer medium to denser medium, what we are saying, the path of light changes. Why the path of light changes means there will be change in speed of light when it is entering from one medium to another medium. So depending on why it changes means depending on its optical density. So speed of light changes. How speed of light changes and what happens when speed of light changes. Now when light is entering from rarer medium to denser medium, rarer medium is nothing but medium which has less optical density, and the denser medium is the medium which has more optical density when compared to the other medium. Now when light ray is entering from rarer medium to denser medium, the speed of light decreases. So when the speed of light decreases, then the light ray bends towards the normal. So it bends towards the normal. See, consider this. When there is no separation, when there is no change in mediums, if these two mediums are same, then there won't be change in path of light. The light ray travels in straight line. That is, it may go like this. But when there is change in medium, one is rarer medium and the other one is denser medium, then the light ray is undergoing changes in path of light because of change in speed of light. So this will be the angle of refraction. So when light ray is entering from rarer medium to denser medium, the speed of light decreases and the refracted ray or the light ray bends towards the normal. So whenever the light ray is entering from rarer medium to denser medium, so angle of incidence is always greater than angle of refraction. So that is angle I is greater than angle R, because it is bending towards the normal with a change in speed of light. So the two conditions which we have to remember from this is when light is entering from rarer medium to denser medium, speed of light decreases and the light ray bends towards the normal. So when the light ray bends towards the normal, angle of incidence is always greater than angle of refraction. So this is first condition. The second one is let us see what happens when light is entering from denser medium to rarer medium, when light is passing from denser medium to rarer medium. Let's take that as second condition. Light is entering from denser medium to rarer medium. Let us take this. Denser medium to rarer medium. So consider this as an interface between two mediums. This is first medium, this is second medium. Let us take this as denser medium. First one is denser and the second one is rarer. Draw a perpendicular and this acts as normal. Now consider a light ray. This is incident ray and this is angle of incidence. So the light ray is coming from denser medium and it is entering to rarer medium. So the density of the optical density of this medium is more and the optical density of this medium is less. So when the light is entering from medium which has more density or optical density to the medium which has low optical density, then the speed of light increases. When the speed of light increases, it moves away from the normal. So that moves away from the normal. So when there is no change in medium, it might go straight. But when there is change in medium, it is bending towards the normal and this will be angle of refraction. So what happens here? This is normal. When light ray enters from denser medium to rarer medium, the speed of light increases, and when the speed of light increases, then the light ray undergoes refraction and it moves away from the normal. When it moves away from the normal, angle of refraction is always greater than angle of incidence. So angle R is greater than angle I. So the two conditions which we come across in this is when light ray is entering from denser medium to rarer medium, speed of light increases. Speed of light increases and the light ray moves away from the normal, and in this condition angle of refraction is always greater than angle of incidence. So for example, why we are saying that light undergoes refraction? Because of change in optical densities of the medium. So for example, if you are moving in a busy street and if you are moving on a bicycle or a vehicle in a busy street, when there is more traffic, we will be using brakes more time. That means the speed will be decreasing. So if we enter into a highway, what happens? We will be moving freely and the speed of the light will be, speed of us will be more. In the same way, when the light ray enters into denser medium, that means the medium which has more density. Let us consider that as a traffic in our sense. So when it is more, when the density is more, the light ray, speed of light decreases and it bends towards the normal. So in the converse to that, when light ray is entering from denser to rarer medium, so when optical density is less, the speed of light increases and it moves away from the normal. And now let us see how the other factor which decides how much the refraction takes place. That means by how much the speed of light decreases or increases. So that can be explained with the help of refractive index. So the other term which we come across in this is refractive index, and based on refractive index we will say that the speed of light increases or decreases and by what factor it increases or decreases. The next topic from refraction is refractive index. Let us see what is refractive index and how we will calculate refractive index. See, refractive index is the ratio of velocity of light in vacuum to the ratio of velocity of light in specific medium. And this is a dimensionless number which says how much the light is bending or by how much the speed of light is decreasing. We are saying that refraction is the process of bending of light or change in path of light when light is entering from one transparent medium to another transparent medium. Now, refractive index says that by how much value will it decreases, its speed decreases, or by how much the bending of light takes place. Let us see refractive index. Refractive index is denoted with letter N or mu. So refractive index is equal to, refractive index N is equal to speed of light in one medium or first medium or one medium to speed of light in other medium. Speed of light in other medium, or we can take that as first medium and second medium. So speed of light or refractive index can be calculated by, for example, if we take speed of light, refractive index of first medium with respect to second medium. N12 represents that refractive index of first medium with respect to second medium. That can be calculated by using speed of light in second medium by speed of light in first medium. Speed of light in first medium. So in the same way, refractive index of second medium with respect to first medium can be calculated, that is N21. That is the refractive index of second medium with respect to first medium. That can be calculated by using the formula speed of light in first medium by speed of light in second medium. Speed of light in second medium. That is N21. Now, for example, if we consider one of the mediums as air or vacuum, so we know the speed of light in air or vacuum, that is 3 into 10 to the power of 8 meter per second. And speed of light in air or vacuum is represented with the letter C. So now, when we consider one medium as air or vacuum, we call that refractive index as absolute refractive index. So absolute refractive index N is equal to speed of light in vacuum, or air, divided by speed of light in other medium or specific medium, other medium. Now if speed of light in vacuum if we take that as C, and speed of light in other medium if we take that as V, velocity, then N is equal to C by V. So this is the formula for finding absolute refractive index. So that is absolute refractive index N is equal to speed of light in vacuum by speed of light in other medium. So this is how we calculate refractive index, and from this we can say how much the speed of light is decreasing or increasing, or by how much the ray of light is bending when it is traveling from one medium to another medium, whether it is when it is traveling from rarer to denser or denser to rarer, by how much value its speed is decreasing, or by how much value its ray of light is bending or changing the path of light. And the other topic which we come across in this is refraction in spherical surfaces. So before going to refraction through spherical surfaces, let us see refraction of light through glass slab. So let us see how light behaves when it is traveling from a glass slab. Refraction through glass slab. Refraction through glass slab. See, rectangular glass slab. So take a sheet of paper and take a rectangular glass slab and mark the outlines of the glass slab. So consider this as rectangular glass slab. So mark the outline of that on the sheet of paper. Now draw a perpendicular to this. It acts as a normal. And take a source of light, and from the source of light, incident light on this by making certain angle. So when light is, so let it be first medium, that is air medium. So from air, the light is entering to glass medium. So this is glass slab. So light is entering from air medium to glass medium. And refractive index of glass is more when compared to air, and air is a rarer medium and glass is a denser medium. So when light is entering from rarer medium to denser medium, what happens? Speed of light decreases, and when speed of light decreases, it bends towards the normal. So the light ray, instead of going straight, it bends towards the normal. And now draw another normal over here. And again, light is entering here from denser medium to rarer medium. From glass slab to, it is again coming out from glass slab and entering to air medium. That is, light is coming from denser medium and it is entering to rarer medium. So when light enters from denser to rarer medium, what happens? Speed of light increases, and when speed of light increases, the ray of light bends away from the normal. So let it be, this is angle of refraction, this is angle of incidence I, and both these two angles will be same. This is angle of refraction, and we call this as emergent angle and this as emergent ray E, and this is angle of incidence and this is refracted ray. This is incident ray, this is refracted ray, and this is emergent ray. So this is the ray which is coming out from the glass slab after undergoing refraction 2 times. So it is, light is undergoing refraction here, that is interface between air and glass, and here again it is undergoing refraction at this edge as it is entering from glass to air, that is denser to rarer medium. So for example, when there is no glass slab here, the light ray might travel in this direction. As there is change in medium, the light is undergoing refraction and it is bending towards the normal here, and again when there is change in medium, it is speed is increasing and it is bending away from the normal. So if we observe these two lines appears to be parallel, that is incident ray and emergent ray appears to be parallel, and this shift, the shift in path of light, we call that as lateral shift. So why why there is change in path of light? Because there is change in medium. As there is change in medium, speed of light is changing, and with the change in speed of light, the path of light is also changing. So what we observe in this is, in refraction through glass slab, when light is entering into glass slab, it is undergoing refraction, and when it is leaving the glass slab, again it undergoes refraction, and the incident ray and the ray that is emergent after double refraction, both of them will be parallel, and there is a shift in between this. If there is no change in path of light, it might move straight. So to that, this is the actual ray that is coming out from the glass slab. So the distance between these two, we call that as shift or lateral shift. So this is what we come across in refraction through glass slab. And in the next topic, we will discuss about refraction in spherical surfaces. Thank you.